Zinc is an essential mineral which is needed for the proper growth and maintenance of our body. It is a key factor in helping hundreds of enzymes work and is needed for immune function, wound healing, blood clotting, thyroid function, and much more. While rare, zinc deficiency in a country like Australia can occur, and there are certain groups particularly at risk. In this podcast, I'll outline the key roles of zinc, what the consequences of deficiency are, and give you suggestions on the best food sources and supplemental forms of zinc. Welcome to the Thinking Nutrition Podcast. My name is Tim Crow, and I'm a career researcher, educator, and science communicator, with most of this spent in the field of nutrition. How do you make sense of so much conflicting information in the field of nutrition? Well, I don't profess to have all the answers in an area that is continually changing as research changes. You can count on what is covered in this podcast to be based on the whole field of nutrition science, not just selective areas that support a particular way of thinking. And this podcast will always be free from any commercial product tie-ins, endorsements, or advertisements. Just credible nutrition science presented in plain and simple language, and then translating this into what it means for your health. So, on with today's show. Zinc is a key mineral with roles in growth and development, immune function, protein synthesis, wound healing, DNA synthesis, and cell division. It has body-wide importance. Add to that its role in blood clotting, thyroid hormone function, taste perception, sperm production, and vitamin A synthesis, then it is clear how important it is to get enough zinc in your diet. How likely, though, are you to be deficient in zinc? The answer is not very. Severe zinc deficiencies are not widespread in industrialized countries in the absence of other diseases, but they can still occur in vulnerable groups, such as pregnant women, premature and low birth weight infants, young children, alcoholics, and people with malnutrition or anorexia nervosa. And it is also seen in people with severe or persistent diarrhea, malabsorption syndromes, including celiac disease, and inflammatory bowel diseases, including Crohn's disease and ulcerative colitis. More globally, though, zinc deficiency is incredibly common, especially in developing countries, with nearly 2 billion people in the developing world considered to be deficient in zinc. Human zinc deficiency was first reported in the 1960s in children and adolescent boys in the Middle East. Children have especially high zinc needs because they are growing rapidly and synthesizing many zinc-containing proteins, while the native diets amongst those populations were not meeting their needs. The consequences of zinc deficiency in childhood include severe growth retardation and immature sexual development. Also, zinc deficiency hinders digestion and absorption, causing diarrhea, which worsens malnutrition, not only for zinc, but for many other nutrients. Zinc deficiency also impairs the immune system, making infections more likely. Among them, gastrointestinal tract infections, which can even worsen malnutrition even more. So symptoms of mild zinc deficiency include diarrhea, decreased immunity, thinning hair, decreased appetite, mood disturbances, dry skin, fertility issues, and impaired wound healing. While chronic zinc deficiency damages the central nervous system and brain and may lead to poor motor development and cognitive performance. And because zinc deficiency directly impairs vitamin A metabolism, vitamin A deficiencies sometimes often appear. So for this case, you could see also impaired immune function related to vitamin A deficiency, as well as poor vision. Zinc deficiency also disturbs thyroid function and the metabolic rate. It also alters taste, causing loss of appetite, as well as slowing down wound healing. In fact, its symptoms are so pervasive that generalized malnutrition and sickness are more likely to be the diagnosis than a simple deficiency of zinc. So let's take a bit of a detour and talk about the common cold. Because while vitamin C gets all of the attention when it comes to treating and preventing the common cold, and check out one of my previous podcasts dedicated to vitamin C to get the lowdown on this, zinc also is a common supplement taken to treat a cold. The use of zinc lozenges within 24 hours of the onset of cold symptoms and taking it continually for every 2 to 3 hours until symptoms resolve has been advocated for reducing the duration of the common cold. But despite the popularity of zinc supplements, controversy over their effectiveness in treating the common cold has raged for decades. So a 2017 systematic review and meta-analysis attempted to sort through the confusion, and I'll link to the review in the show notes. The review included data from 7 clinical trials, and it suggests that zinc supplements given within hours of the onset of the symptoms of a cold can reduce the duration of the illness by a third. There was no evidence, though, that zinc doses over 100 milligrams per day can lead to a greater benefit in the treatment of the common cold, with most trials using doses in the range of 80 to 92 milligrams per day. But these sorts of doses are only meant to be used for a short time, as they are well above what is considered an upper level of safe intake. Adverse events associated with chronic intake of supplemental zinc at high doses include suppression of the immune response, decrease in high-density lipoprotein cholesterol, and reduced copper status. So back to the review paper on treating the common cold and the forms of zinc used. Both zinc acetate and zinc gluconate formulations showed a benefit, with a slight, non-significant greater benefit seen with the zinc acetate form. Even with the positive findings from this review, because of the differences in study populations, dosages, formulations, and duration of treatment, it is difficult at this stage to make firm recommendations about the dose, formulation, and duration that should be used for the general public. But there does appear to be a benefit of zinc here. And who would not want to have their cough, sniffles, and aching body symptoms relieved and back to normal human functioning quicker? It is unclear, though, if zinc supplements will reduce the risk of getting colds in the first place. So most of the evidence here is about zinc reducing the duration that you have the symptoms. So while I'm on the topic of supplements, let's talk general dosages and forms of zinc. Zinc has 2 standard dosages, that being a low dosage in the range of 5 to 10 milligrams per day, and again what is considered a high dose, which is around 25 to 45 milligrams per day. For context, the RDI for zinc in Australia for men is 14 milligrams per day, and for women it is 8 milligrams per day, with greater amounts needed during pregnancy and lactation. A low-dose zinc supplement works well as a daily preventative, while the higher dosage should only be really considered by someone at risk for a zinc deficiency. Zinc citrate at 50 milligrams of elemental zinc, which is 146 milligrams of the zinc citrate complex, taken daily for 4 weeks, is associated with maintenance of zinc status. Another form of zinc, that being zinc gluconate at 50 milligrams of elemental zinc, which is 385 milligrams of the zinc gluconate complex, appears to be slightly more effective than zinc citrate. And zinc picolinate is another popular zinc supplement, and again at 50 milligrams of elemental zinc, which is 144 milligrams of the zinc picolinate complex, it may have a greater benefit in increasing body stores of zinc compared to the citrate and gluconate forms. So that's supplements done. But what are the best food sources of zinc? Zinc is highest in protein-rich foods, such as shellfish, and especially oysters, which contain more zinc per serving than any other food. As well as you'll find zinc in meats, poultry, milk, and cheese. Phytates, which are found in whole grain foods, cereals, and legumes, can bind to zinc and reduce its absorption. But these foods are still a good source of zinc if eaten in large amounts. The requirement for dietary zinc may be as much as 50% greater for vegetarians, particularly strict vegetarians, whose major staples are grains and legumes, which contains a lot of these phytate substances. So now onto my research wrap-up segment, where I profile a study that has grabbed my attention during the week. The adage that breast is best exists because of the many benefits that breastfeeding has on both mother and infant. Now, new research finds another reason to support breastfeeding, this time by seeding good bacteria in the digestive system of infants. The gut microbiome is about the hottest area of research going around. The gut microbiome is made up of all of the resident bacteria, viruses, and other microbes that have colonized our gastrointestinal tract. Running all the way from the esophagus to the colon, the microbiome creates its own mini ecosystem, in the same way that plants, animals, and insects live together in their own delicate ecosystem in a rainforest. The gut microbiome, though, is not static. It changes throughout life after first colonizing the gut shortly after birth. Variation is highest during childhood, and it gradually decreases with age, illness, antibiotic use, fever, stress, injury, and dietary changes, all of which can affect the blend of microbes that make up the microbiome. Now, the initial stage of gut colonization during and after birth is an important part in shaping the future health of the infant. Breastfed infants do have a different microbiota signature compared to formula-fed infants, and this could explain some of the immune-enhancing protection that breastfeeding seems to offer. Breast milk contains a diverse population of bacteria, but not as much is known about how the degree that the milk and the physical contact of feeding can have in changing the microbiota of the infant. So now we have a new research study that looked at 107 breastfeeding mother-infant pairs and measured the bacterial communities growing in the gut of the infant in the first few months after birth. And I'll link to the study in the show notes. 28% of the gut bacteria in the infants were found to originate from breast milk. A further 10% of the bacteria came from the skin around the mother's nipple. So that adds up to almost 40% of the bacteria in the infant's gut originating directly as a result of breastfeeding. But why is this important? Bacterial diversity is an indicator for a healthy microbiome. Infants in this latest study who were breastfed had a more diverse microbiome, and this increased with the amount of milk they received each day, and even in the weaning period when solids were being introduced, in addition to supplemental breastfeeding. This research has identified another way breastfeeding can contribute to the health of babies by seeding and feeding a thriving population of gut microbes. The process of establishing the gut microbiota in infancy has the potential to be a key determinant of lifelong health. So that's it for today's show. You can find the show notes either in the app you're listening to this podcast on, if it supports it, or else head over to my webpage at thinkingnutrition.com.au and click on the podcast section to find this episode to read the show notes. If you find this podcast of value, then please consider sharing it with your friends and colleagues, or maybe even leave a review. This all helps increase the ranking and reach of the podcast, which means a big win for credible, evidence-based nutrition messages while helping to dilute out the crazy and making the world a slightly less confusing place. I'm Tim Crow, and you've been listening to Thinking Nutrition.